Additionally, when we're looking at sets and Venn diagrams, we have two sets, two different types of sets. We have a finite set, and we also have an infinite set, which I believe we talked about before. The finite set has a specific number of elements. For example, set V is the set of all vowels, and it has A, E, I, O, and U. That's it. So there's a set number. But if we look at an infinite set of elements, for example, positive integers, this is infinite because it's going to continue on forever without end. Now, we also have something that's called subsets. And what is a subset? Subset is just a set within a set. So if I have a larger group of numbers, for example, let's do set A, and let's say set A equals integers, positive integers, up to 10. So it looks something like this. And then let's say within set A, let's say I also have another set, let's call this, well, let's just go ahead and go, so let's call this set N. And this is even integers up to 10. In this case, I can look and I can see that everything that is in N is also in A. Oh, I messed that one up. So 2, 4, 6, 8, 10. Everything in N is also in A. Now, if this is the case, then I can say that set N is a subset of A. Now, if we're putting that on a Venn diagram, it would look something like if this is A, then N would be inside of here. And again, everything that is in N, in this case it's 2, 4, 6, 8, and 10, those are also in A. Well, what is left in A would be 1, 3, 5, 7, 9. So all of the odd numbers up through 10. A few other symbols that you need to be aware of. You need to also be familiar with the symbols for union and the symbols for intersection. So this large U symbolizes the union of two sets, and the upside down U is the intersection of the two sets. And we put these in everyday language, and when you think about the union of two sets, this would translate as or. And then if you think of the intersection, this is two words, both and. Well, what would this look like? A couple of things. So this would be, if we're doing, again, let's do set A here, and let's draw it a little bit differently this time, and then set N here. Put this one into different colors so it's a little more obvious. So here's set N. So let's start in the center, and we can notate here in this section, this small football, these are numbers that are in both A and N. So goes right here. So this is going to be both A and N. So let's go ahead and mark which numbers are in both A and N. Well, 2 is, so 2 would go in here. 4 is, 6 is, 8 is, and 10 is. So it's 2, 4, 6. I'm running out of room here, but 2, 4, 6, 8, 10. So these numbers are in both A and N. Now, when you think of the intersection, so that's what you'll think of, and again, that's the upside down U. But when we're talking about the union, which is this thing, so union equals OR. Now what do I mean by OR? Well, if we have set A here, and then we have set N, okay, if I'm shading, the numbers here, these are in A or N. In this case, they happen to be in just A, but they're in A or N. That's a true statement. Now, the numbers that are here, these are also in A or N. They happen to be in just N, but that's still a true statement that they are in A or in N. Now, what about these numbers in here? Well, they are in N. They're also in A. Okay, but this is still a true statement that these are in A or N. They just happen to be in both. So when you think of the union, what we're doing is essentially we're fusing these two sets. So the union, or A union N, would look like this, where it's everything that's in A, so all of these plus everything that's in N. And if a number occurs twice, we aren't going to write it twice. We're just going to write it once. So A union N would be the following numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be A union N. Now, sometimes you're going to run across sets that don't have anything in common. So there's nothing in this middle portion here. And these are what we call disjoint or mutually exclusive sets. In other words, they have absolutely nothing in common. Well, let's look and see if we can find a set like that. Well, what if we had, for example, let's do positive integers. So positive integers would be 1, 2, 3, infinite. Now let's look at negative integers. This would be -1, -2, -3, infinite. These two sets are disjoint or mutually exclusive sets because they don't have anything in common at all, nothing.